All right, so the one thing I wanted to make sure we spend a little bit more time on, and I briefly mentioned at the end of last class, and that is the idea of memoization. So a memoization is a technique to essentially increase the speed of an algorithm at the cost of using more memory. And this is something we're going to get into a little bit more after spring break. After spring break, we're going to talk about object-oriented programming classes. We're going to talk about algorithmic complexity, and then we're going to do a little bit of graphical user interface programming, and then we're going to pretty much be at summer. So we don't have a whole lot left. You guys pretty much have the basics of programming down. So that's kind of exciting that you could take any idea from this course and just run with it. And if anyone else makes the next Wordle, you guys at least owe me like $1,000 if you when you sell it for $1 million. Because we're gonna learn the next project. If you looked at it, we're gonna look at Wordle, and the simplicity of that game is almost painful. Like, why couldn't we do that? But before we get there, let's talk about memoization again. Remember last time we were talking about our Fibonacci function. Our goal there is just to go ahead and it's going to take some integer, and it's going to return some integer based off of the Fibonacci formula. So if we remember the general recursive algorithm is if the n that is inputted is less than 2, we'll just go ahead and return 1. Actually, it should be less than or equal to 2. The first two Fibonacci numbers are 1. And the other scenario is where we do the recursive call where we return fib of n minus 1 plus fib of n minus 2. So again, we've coded this up a couple times already. A little typo up there in red is telling me that, remember type hinting, the arrow is pointing to the return type. So I was pretty cautious when I wrote the next project starter code, and I tried to put type hints in. So don't change the type hints because I'm going to show you that basically at this point you guys could basically set up an autograder for yourself, and I'll show you kind of how to start that. So it's just a little bit easier than typing in the text every time you need to like experiment with something. So I'm going to give you some debugging tips. But anyway, is everyone okay with what these type hints mean and how to interpret those? Okay, just want to make sure. And then just to go ahead and call this, let's go ahead and call this with a fairly large number. Let's go ahead and just call it with like 37. And that is going to return some value. Let's just go ahead and print it. And if you recall, this does take a few seconds right here to go ahead and go through the recursive tree. And again, we'll review recursive trees a little bit because that's going to be something that's going to show up after spring break as we get into asymptotic complexity. To time this, what you could always do is from time import time. And then you can just go ahead and time is a function where it's just going to take a quick look at the clock of your computer, and it's going to store whatever the current time of your computer is in this start variable. And then we'll go ahead and do another quick look at the clock and store in that the end time. And we can use this to go ahead and figure out, let's see. Let's go ahead and see how long it took. So we'll just go ahead and say fib of 37 took, and then we'll just go ahead and put in the end minus the start, and that would be seconds. So this is a quick way to go ahead and time something. So if we run this, you can now see that. And what did it take us? About, I don't know, maybe like 6-7 seconds. It's taking its time is what it's taking. So you can see, wow, 9 seconds. So this is the standard Fibonacci algorithm without any sort of memoization. Any questions on that? All right. Now, what we could go ahead and do when we learned last time about dictionaries. So again, I'm going to just kind of move this down a little bit, and I'll put this down here. I'm going to go ahead and write a new function just so we can time and look at the difference and call this one fib memo. Memo, of course, being for memoization. there's another type of kind of this process called tabulation, which again we might look at later, but we're gonna just focus on memoization for the time being. It's basically a down-up, it's top-down versus bottom-up approach. But the thing that we're gonna do is we're gonna still get the nth Fibonacci number, but we're going to have a second formal parameter, and that formal parameter we'll call memo. It is of type dictionary. And what I'm going to do is I'm going to give it a default value of an empty dictionary. The reason I'm giving it a default value of an empty dictionary is because if you do, by giving it a default value, what we could go ahead and do is essentially, if we want to call this fib memo, and we just wanted to do 37, remember if you give it a default value, you don't have to put in a second parameter, but if you already had some information, like you knew that like 1 was 1 and 2 was also 1, you could also go ahead and put that in there. But just to keep the function kind of nice for the user, I'm going to give it a default value of an empty dictionary. And we'll call that dictionary memo. And again, this is going to return an integer value. So that is the definition of the function, and it's going to be more or less the same, but we're going to have to do one different thing. Memoization let's start with this. Let's just see what the main difference would be is this. So if n is less than or equal to 2, this is the base cases. The base case stays the same. So if n is less than or equal to 2, we're just going to go ahead and return 1. Else, this is where it's going to go ahead and change. We're going to, yes, we're still going to go ahead and compute the value of the previous two, fib of n minus 2 plus fib of n minus 1, but instead of immediately returning it, what we're going to go ahead and do is store that in the memo, in the dictionary. So, forgot the fib. And by the way, I shouldn't say fib because this is recursive, so this should now be fib of memo. And there's what I'm going to pass into it, just so it's going to then be fib underscore memo and minus 1. Technically, I think to master it above, that should be 1, this should be 2. It doesn't really matter, it's just addition. And we all know an addition is commutative, or for those of you in abstract algebra, a billion. And now that you have stored that in here, you'll go ahead and return memo of n. And by the way, lookup time in a dictionary is very fast. It's said to be in constant time. More on that later. So there's one other thing that we need to go ahead and do to go ahead and complete the memoization. Just to kind of see how things, let's go ahead and just copy this code and then paste it down below and see what happens if we were to do fib of memo of 37. And let's just, everyone, there's a lot there. Let's go ahead and run this and see what happens. So the first one, again, what did that take us to before? About 9 seconds, right? That was about 9. So, 7 seconds. It sped up this time. And again, the reason for the change is because, again, we're running on basically someone else's computer, and their computer might be doing other things. We're using a cloud-based service. So if we're looking at this, fib of memo, which is going to be the second one, I should go ahead and call this here, is taking a little bit more time. It took 13 seconds. So that extra 6 seconds, anyone think what caused that extra 6 seconds in this second algorithm? Where did that extra time come from? Or why did that second one need more time? Any ideas? It was this right here. It was the storing it. So again, in the first one, we just went ahead, returned it, added it back together. In the second one, we're actually storing it in a dictionary. And if you think about it, it's doing a lot of extra calls to go ahead and store that, and we're not using it. So that's the other thing that we need to go ahead and adjust. So if we go ahead, the first thing should be, if n is in the memo, what we want to do is not do any sort of other recursive calls. We just want to immediately go ahead and look up that value of n as the key. And remember, by default, n is going to check the keys of the dictionary. And then if that key is in the dictionary, you can go ahead and retrieve it. Remember, you should always check a key is in the dictionary before you try to retrieve it. And of course, if you do that, you need to change the second condition to an else if or an elif. And now if we run this, you can see that the first algorithm, what is that going to take? Again, 7 to 9 seconds. Let's give it a moment. But the second one should be drastically faster. Should be. What's if I mistype something? Hold on. Fib of memo. Return memo of n. Yeah. So it looked like there was a lie right there. But you can see that this one, again, I forgot to change this. So this is technically fib of memo. I just forgot to retype the string. Look at how much faster just using that little extra time to store took off of the actual computation of a fib of 37. So it went from 9 seconds to how many? So tenths, hundredths, thousandths, 10,000ths, about a 600ths of a second. So pretty good investment for just a little extra storage. So that's memoization. It is a way to basically reduce the number of recursive calls. And let's go ahead and visualize that through a tree. But any questions on just the algorithm and how we implemented memoization? No? All right. So I really like this. Free Code Camp is, by the way, a great YouTube channel. If you're ever looking for just something to watch, they have so many cool videos, and it's amazing that it's all free. Anyway, let's go ahead and just watch this a little bit of this guy. Hold on. You guys don't hear anything, right? I have to always figure out how to change the sound. So let's go through the speakers. Whoa. Nope. Let's try one more time. Not display. Is it still running? Let's go through external headphones. Can you all hear that? Nope. Do y'all hear anything? All right, so here, I'll just kind of talk through this. So here is the, so you can see right here is for computing fib of 6. If you look at this, we go all the way down to the left until we hit our base cases. And the way this would go back up, let's just go ahead and click forward a few seconds. You can see right here, we have our 2 base cases. And then we return those because that's the n is less than 2 case. But this is where the memoization kicks in. You can see over here we have a dictionary called memo. And before it returns it, this is where we did memo of n is equal to fib of n minus 2 plus fib of n minus 1. So you can see it stored it before it returned. So if we go ahead and then look at this right here, we're also, before we return it, we're going to store it. And we're now at fib of 4. So actually, we did ours a little bit different. We actually stored at the last, did we store them? I don't think so. But anyway, here's the non-base cases stored in memoization. But notice when you look at this 4 is also occurring over here. So before it actually goes and does that computation, it's going to check the memo to see if it's in there. And you can see, let's go over, it's going to do 3, it's going to add it, it's already in there. So notice that those 2 calls disappeared because it doesn't need to do those since it is going to already just look into the dictionary, the memo, and return it directly as the value using that key as a lookup. So it goes all the way here, and then this is where you can start to see the power of memoization. All of these calls are essentially going to disappear because 4 is already in the dictionary. So you can just see this one basic example got rid of a lot of actual function calls. And it might be worthwhile to just go ahead and look at the generalization of it. Let's go ahead, we talk about it right here. So you have this right here, so this is what it works out to. Take a moment and think, what would fib of 7 look like? If I wanted to do fib of 7, what would the actual structure look like? Anyone explain maybe like what would change if we were to do 6 or 7 instead of 6? Any ideas?
It looked like that, but also a 7 with
Exactly. So if we were to do fib of 7, it would just go ahead and add one more node up here. So let's kind of think about how many nodes are here in terms of the actual input. So n was equal to 7. So if we look at, count how many nodes there are here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11. But the ones that you should focus on, if you look down the left, what do you notice about these numbers here on the left? What are they doing? They're decreasing, right? How fast are they decreasing? Or what do you notice is the pattern going 7, 6, 5, 4, 3, 2? It's linear. So what we could go ahead, if we looked at this and kind of extended this, there's this counting down from 9 to 2 on the left, but we have to also go ahead and look here. So you have 7, 6, 5, 4, 3, 2, 1. So it seems like, let's see where it puts it in the video. So that's where it's talking about the linear. So there's n, but then you have the ones going off to the left or off to the right there in blue. That's again approximately n. So again, that's 2n. And if you think about it, once you start getting so large that these are more or less not going to be very different. If you start thinking about the limit as n goes to infinity, that 2 does not mean much. So what you could go ahead and say, and we'll talk about this more after break, the time complexity is big O. Yes, it's literally called big O notation. Big O of n, and it's essentially ignoring constants. And this big O of n space is this how much the dictionary cost. It basically it grew in size relative to just the size of the input. If you were to go back, I think earlier in the video, if before the memoization, let's see if that's right here, it would be right. I think it would be right about here. Before the memoization, the time complexity was 2 to the n. And that would basically be how many nodes there were in that tree. So memoization really allowed us to go ahead and just reduce the time complexity from something that was exponential to something that was linear. And if you compare the graphs of a linear and exponential, what a difference, right? The linear grows a lot less than the exponential. More on that after break, though. Any questions? And this is, by the way, I would encourage you to look at this whole video. I mean, it's a good 5-hour listen. I haven't got through all of it. But it does a bunch of different problems, like the grid traveler, something that's just multi-dimensional or two-dimensional. But basically, this one's talking about how long would it take for him to get to a certain location. We have the tabulation method, which is kind of a different approach to populating it. But this is a type of problem called dynamic programming. So where you basically break a problem down into smaller ones, which is exactly what we're doing with recursion. Yeah.
Is that video on
It is in the class notes. So write down, where is it? Let's see. Yeah, so if you go down right here, Free Kid Camp, lots of really good videos on there. It's amazing the access you have to free education. So take advantage of, why you can get this for free it's a little bit harder to get someone to look at your code with you and do a code review and help you through the hard part. So take advantage of me in the context of me helping you with your learning. But any questions? So one thing, maybe let's transition. If you want to go ahead and pull up the starter code. Just let's go ahead and look at the project together. Let me give you some tips on how to approach it. Let me go ahead and kind of highlight a couple things about the project 3, which is called Wordy. So that's just kind of what you're going to be looking at. A lot of strings here, lots of words. So go ahead and pull up the starter code. I'm going to give you some tips on how to maybe debug, how to develop. One thing that it took me a while to understand, and I always remember this when I first learned programming, is like how do you start using like different files? Like my problem seems so simple. Like how am I going to just have a 10,000 line file with everything that I want to do? No, that's terrible. One thing you can do is organize your project into different files, and that's what we do here. And I just kind of maybe want to show you how to approach this. So now that we have functions, things should be so much easier to work with in terms of kind of breaking up your project. So you all find where the project was, you all ready? So my recommendation is to go ahead and start in the main.py file. So again, this is going to basically be where I launch certain things. So if you look at this, if you were to just run this right from the get-go, you can see that it is telling you essentially what's happening right here. So we're calling readability with text. Then I went ahead and I'm calling Caesar, I'm calling Visionaire, and then it looks like we're even calling my Wordle. So each of these parts so part 1 is readability. And if you look at the actual project description for readability, it is very wordy, so I did break it up to try to separate this up for you all. But I have all these test cases down here for you at the bottom. Did you all have a chance to read through what we're doing in readability? If not, essentially what this should do is we're going to pass in some bit of text, and it is going to use this Coleman Liu index. Any relation? Anyone in your family do this? No, not your family? Yeah, so the piece of cake, right? Anyway, this is going to do this computation and is going to give you essentially the reading level of this piece of text. So 1 fish, 2 fish, red fish, blue fish is before grade 1. And of course, we do have down here much longer, something a little bit more complicated. A large class of computational problems involve determination of properties of graph, digraphs, integers, array of integers, finite families of finite sets, Boolean formulas, and elements of other countable domains. Boy, is that math for you or what? Obviously, it looks like your math textbooks, right? So grade 16 or higher. And it's, again, essentially looking at the size of the words. This formula doesn't really necessarily look at like the domain knowledge required to read the words. It's just looking purely at length per 100 words. So be very careful, like when you're reading as you go through this. Where's that formula right here? It's right up here. As I was working on this problem last night, I was kept running into a bug because guess what? I didn't read it 12 times. So one thing that you do want to make sure, L is the average number of letters per 100 words. I kept missing this per 100 words, and my numbers, this is a reading level of 37. I'm like, no, that sounds way too high. So make sure you're careful what L and S is. But if you haven't read through those, read through those carefully. But what you could now do, the way I set this up, if you had read it before, I did make some changes last night. Last night it was basically calling input. It was just asking the user for input, but what I did is I transitioned it to a function. So you can see right here, this function is going to take a text and it's going to return string. And again, that's just the data type. And what you're doing in main right here is, because if you always hit run, it's going to always call the main file. So what I have set up right here is a comparison between test cases and the test output. So you could quickly actually notice up here at the top, I imported from the readability file the readability function. So again, just what this is saying, it's like an overlap of language. So from the readability file, import this function. So again, Wordle, the main function is called main. So from Wordle, we're importing main. And that allows me to call these functions within this main file. Is everyone okay with what I'm doing up here? All right. So instead of having to like type in one fish, blue fish, or one fish, two fish, red fish, blue fish, oh boy, that's going to come off the tongue. That's a little tongue twister. What I did is I just stored a couple test cases in a list, and I'm just going to go ahead and iterate through the list. Look what I'm doing here. I'm grabbing the text from my test case, and then I'm passing that test case into readability, and then I'm storing the resulting one in this result variable, and then I'm just going to print calling readability with text so-and-so. So if you run this, notice, yes, it appears twice, but realize that does anyone catch where this second print statement is coming from? Well, technically that second print statement is this one, but the first print statement is me just calling it right here. So technically if I just got rid of that, you can see it'll just still run in a moment. Oh, it's because I need to do ... It doesn't like an empty function definition. So let's do that. And now you can see it only occurred once. So that should help you in a testing all of your cases. So you no longer have to copy and paste it every time you need a test. You can just go ahead and store them in this data structure, this list, and just go and call that with different functions. So does everyone see this commented assert line here? What you could go ahead and do, if I uncomment this, what this assert does, it is going to check if the result is equal to the test output at index I. So you can see right here, I essentially have the answers what I want. So the fact that the function is not correct, when I go ahead and run this, you can see it's going to stop right there, and it is going to essentially say line 26, and you could always say something like the result, and you can actually put another comment in and say expected, let me use this, test case, and then we'll just do like I. All right, so if we go ahead and run this now, you can see it's telling you what test case failed. So that's going to give you maybe a quicker way to debug than to copy and paste things. I mean, by all means, if you always want to copy and paste, by all means, feel free. But I essentially set up the first two test cases for you. Does that make sense? Bailey, you with us? Okay. All right. The other thing, once you're done with that, if you're done with readability, you may just comment that out, and then you could focus on Caesar or Visionaire or main 5. So that's going to really hopefully reduce the tedious of testing things, but you may even want to get rid of the for loop. So that's one thing that I set up to help you debug this next one. All right. Any other questions on this one? All right. Let's go ahead and talk about Wordle for a sec. So if you look at Wordle, there's a lot of starter code here for you. Honestly, I think you probably could have filled out the starter code, but the project was kind of long enough already, so I wanted to go ahead and give you some help with the starter code. So I'm going to just hit run, and notice here how this is playing out. It's going to have down here the if name is equal to main, run this, and we'll talk about command line arguments a little bit. But what I've done is I've essentially hard-coded the word size to 5. So I do want you to learn a little bit about command line arguments, so I'm going to show you what I mean by that here in a moment. So what a command line argument is, hold on, let me get, where am I oriented at here? All right, let's say it like this. So let's go to my Wordle. So you can see, so look at it here, this first line is how you're going to run the program. And what a command line argument is remember like those first few days we just went to the shell, we typed Python to basically get up the interpreter, we called in some file, but we didn't have any extra things before. We would just basically do Python, name of a file, and then that was it. What you could do is you can actually pass in values from the command line, and the program could use those. So if we go over here, now let me go back to here. You can see down here at the bottom, I have this args. Args is short for arguments. And we see sys.argv. Sys is a module that is essentially looking at the system. And what I did is I passed in 5 to the system. So maybe just to see it, let's go ahead and print args. But what I'm going to go ahead and do is instead of using main, I'm going to go over here to the shell. I'm going to type Python. Let me zoom this over. Python. I'm going to do wordle.py, and then I'm going to go ahead and pass in, let's say, 8. And you can see right here, it printed the arguments that it got from the system. The first argument was the name of the file. The second one was some, again, string, not int, which is why I casted it here. So again, the Wordle is not going. Your version of Wordle is not going to be restricted to 5-letter words. It is going to be either 5, 6, 7, or 8-letter words based off of the ones that was passed in. So I kind of want you to kind of read through kind of how this code works. And the first to do of this project, or this part of the project, is to essentially guard against improper usage. So again, you can bypass this part by just calling it with the formal parameter like main of 5, like we did in main. But I do want you to spend a little bit of time learning about command lines, and just by example right there should show you the basic usage of it. So that is command line arguments. The other thing that I just wanted to kind of show you what is happening. In this Wordle folder, there is a bunch of words. So you can see right here, there's 1,000 words in here that you're going to randomly pick one, or not say you, but I'll say your program should randomly pick one. So if we go look at wordle.py, and let me find where that code is. In main, you can see right here, we have target equal to choose word. Choose word is already implemented for you. And let's go down to that and just show you its implementation. It's a simple function, but something we haven't seen before. I just want to show you what this does. So by the way, I'm going to run this. I'm going to go ahead and print words. And you can see in words, it stored all of the lines that were in the file that is located in Wordle. And then again, word size, we just pass in, and it just looks up that text file. So if I went ahead and, let's go ahead and just do this the same way. You can see I passed an 8, so it went ahead and retrieved all 8-letter words that were in that file. So the reason I wanted to show you this, as you're debugging, don't you all hate randomness? You want things to behave the same way. So by the way, let's see what word it chooses. Let's just run it a couple times. So let's go ahead and just print the word that it chose. So let's just run it here. Go to the shell. So it chose the word membrane. Okay. Second time it chose the word handheld. Third time it chose the word assessed. So does anyone remember? Maybe you just want to kind of like get the hang of it using the same word each time. Does anyone remember how we would go ahead and basically set the random number generator or the randomness to always start the same? Seed. So again, don't leave this in your final program, but as you're debugging, it might be a good idea just to, you could either add seed to the top here. Choice, by the way, choice is a method in the random module that allows you essentially to just choose a random item from a list. So instead of choosing an index, we're just choosing a random number or random word from the list. So if you want, you can always just help you out. from random import seed, and then you can go ahead and just seed, and let's just say seed it with 1. But now you can see that every time it is picking, let's see, where is that? I lost. Oh, because I accidentally removed the print. So print word. But now let's try that. Positive, positive, positive. You can see it's always choosing positive. Nice mathy word there. How about that? Anyway, that's a quick little tip on working on this part of the project. Remember, of course, don't leave that in there. I will probably I'm working on the auto grader for me, and if I should get it done in time, I'll share it. But any questions on the starter code? The other fun part of the project is going to be Caesar and Visionaire. These are essentially just cryptography. You can see how Caesar works. If you start with a letter, you can go ahead and if you add 1 to H, what letter comes after H is I. If you add 1 to E, you get F. And again, my recommendation is to remember, does anyone remember what function you can use? Oops, that didn't work. What function you can use to go ahead and get the ASCII representation of a character? Remember that you can always call the ORD function, and that'll give you the numeric or ASCII representation of a letter. But I think it's going to be a really fun project, or 4 parts of them. So the Wordle one, I'm excited. I think that'll be fun. The cryptography ones, Caesar and Visionaire, kind of mysterious. And the readability, we all got to read. Any questions? Yeah, Kenneth.
So do we need to create functions that like ask the user for an input, or are those already in there?
So you won't need to go ahead and create functions that ask the user for input. So if you look at the code provided for you, you see I've already basically set, you're basically going to have to fill out this function. The good part about the way we're doing this is now instead of asking the user for input, we're just doing functions, or we're just working with functions. Let's suppose you wanted to like test a bunch of values. So what you can always do is just go into main. You could go ahead and think about like, okay, Caesar of passing in hello with a key of 1. This should, is the example here. It should print IFMMP. So what you can always do, you can just go ahead and print that result if you just want to see it. The other thing you can do is you can just assert that Caesar of hello 1 is equal to, what did I say? What was it? IFMMP. So you can actually really quickly check if your code is correct by just calling the function with some input and some key and seeing if it's equal to what you expect.
Okay, but for Wordle, we need to have user input of some kind, yes?
Okay, so we're not talking about Wordle. On Wordle, yes, you could go ahead and you will need to go ahead and implement that. Where is that? I think that is this get guess. So that is to do number 3. And it kind of talks about how you want to implement, or how you're going to implement that within the docstring. So yeah, in Wordle, it's going to be a little bit more manual. And I would encourage you to kind of play around with, you can actually, like, maybe you get part 3 working, you can maybe hard code the guess. So like, okay, you got guess working, but instead of constantly working with, let's see, where is that? Where is the get guess? What you could always do is just like comment this out and just say, okay, I'm gonna always have them guess, 8-letter word, banana. I don't know if that's 8 letters. It's just what came to my mind. That's 7. So you could always like hard code parts of it to get certain behavior to go to the next part. So that's one thing that you can do that might speed up your development process by basically forcing certain variables a certain way. Is that what you were asking?
Yeah.
But yes, get guess is going to ask the user for input, but it'd be kind of annoying if you're working on to do 4 if you have to keep typing in the same letters. So go ahead and just hard code it, and then of course make sure functionality works again at the end. So incremental development. So, all right. I'll have this recorded. I did dump a lot of tips on you. So if you're finding something tedious, especially as we start having more and more things, if you're ever like, hey, is there a way that I could shortcut this development process, feel free to reach out to me, because again, there are little debugging tips that you pick up over the years that I'd be happy to share as you run into similar issues that I have. Any questions on anything we talked about today? All right. We have about 7 minutes left, so I'm going to stop the recording, and what I'll say is feel free to peruse the project, and if you have any questions on anything, let me know.